I've got the top of the hour, and I want to welcome everybody to our From Research to Implementation webinar series. This is our August installment here. My name is Travis Walbeck. I'm the training manager here at NCAT. This week's topic is the implementation of pavement preservation curves. And then what we're looking at with this one here is using these benefit curves to manage our pavements and make them last longer. We've got a familiar face, and we've got somebody we've not had on here with this particular series today. So we've got Buzz Powell is obviously going to lead us off again, and then we've got Dr. Adriana Vargas, who's here as well. That she runs most of our preservation research here at NCAT. So again, Buzz worked for 12 years with the Alabama DOT and 2 years as in the private sector before becoming NCAT's first test track manager in 1999. He's now the NCAT Associate Director at Auburn University and a research professor as well. Dr. Adriana Vargas, she received both her master's and her PhD from Auburn University. She worked in the private sector, managing pavements and doing pavement design. And she also was a professor and a researcher at the University of Costa Rica. She's currently an assistant research professor here at NCAT. Her main area of research is pavement preservation and pavement management. She's the lead PI for the NCAT and Min-Road Partnership Preservation Group study, and that's a pooled fund research effort that aims at determining the life-extending benefit of various preservation treatments as a function of the initial condition and then the traffic level and climate. And I'm sure she'll touch on that a little bit with you. Many of you, from seeing the list of who's on here, have seen her speak before, so we're used to seeing that. Again, I'd like to invite everybody to go ahead and throw any questions you have in the chat box. I'll help monitor that, and we'll get those answered at the end. And given that, I want to go ahead and turn the time over to Buzz, and let's get started.
Oh, well, thanks, Travis, and good morning, everybody. I'm really happy to be with y'all again this morning, as Travis said, to talk about implementation of pavement preservation benefit curves. And this is something that I am really passionate about ever since we started preservation research here, because when I started my career with Alabama DOT in 1986, I worked in pavement management. So it was all about building curves for all the different types of surfaces that we had on Alabama's state network. So I'm really excited about us doing research now to kind of fine tune that process just a little bit here at the National Center for Asphalt Technology. So the content for the webinar today, we've got it split up into, I'm going to go through background as I customarily do, as Travis said. Then I'm going to hand off to the expert, to Dr. Adriana Vargas, and she's going to go through the process of determining life extension and condition improvement, the two different benefits that we commonly talk about. She's going to do a web demonstration, and this is the really practical part of the webinar, because what we really want to do is equip people to dig into the data and use the data as part of their decision-making process. And then I'm going to land us with some takeaways at the very end. Of course, as is usually the case in our implementation webinars, the NCAT pavement test track is sort of the starting point for what we do. The track has been around since 2000, and the original research was all about the performance of surface mixes. So it was about mixing materials. In 2003, we started ripping out really thick perpetual pavements and building thinner pavements and doing structural pavement research. And then in 2012, we started doing pavement preservation research. So we do research at the track that is in response to the pressing needs that state DOTs have, that FHWA has, and then that private sector partners have. And then about in 2010 we started doing the research 10 years ago, but 11 or 12 years ago was when we really started doing a deep dive on pavement preservation, because that's what we were hearing was the great need from our DOT participants at the NCAT pavement test track. Of course, when we do research at the track, if you think about kind of the life cycle curve of a pavement, we've got stuff out here even now that is at all different points along this curve. And that's because that's the objective of the research that we're doing. In many cases, when we're doing structural pavement test sections, the sponsors want us to take them all the way out to failure. But in practice, what you want to do is catch pavements and keep them from falling too far down that curve, because the farther down that curve you get, the more money you have to spend per mile or per square yard in order to maintain the serviceability on those roadways. So when we talk about pavement preservation, really quickly, what you want to do is stay kind of in the upper, mostly the upper third, half to third of that curve. And the research that we do is all about equipping you to select the alternatives that you have so that you can achieve the lowest possible life cycle cost for your roadway network. So we always talk about safe and sustainable asphalt pavements at the lowest possible life cycle cost, and pavement preservation is a really important part of that. So the need for this research, kind of to go back to 2010, 2011, was pretty great, because if you looked at the resources that were available, and I'm going to pick on microsurfacing versus thin lays, because that's often a decision that agencies and owners are going to make. Do I want to use one or the other? And if you looked at the research or the reference material that was out there in the early 2000s, early to mid 2000s, you didn't have a lot of guidance on, well, how long are these going to last? You know, when you start to evaluate your alternatives. National Center for Pavement Preservation, back in the mid to late 2000s, they had a table that was really useful, that they promoted it when they did presentations, that related pavement condition index to different lengths of life that you would expect to get from alternatives. But again, when you look at, in this case, microsurface versus thin lays, that what agencies would typically do is say, okay, well, I'm going to pick the midpoint there and say that's about 5 years to 5 years. And in practice, what a lot of agencies still do is they say, okay, well, I'm just going to assume that both of those are going to last 5 years. So it all goes back to just, well, what's my cost per mile to do those different treatments, because I'm going to program in the same performance life for the two of them. And this is not ideal. You know, what we know is that when we apply all these different treatments to roads that are in good condition, they last a lot longer than they do if we apply them when they're in fair to poor condition. But quantifying that really is our challenge. The R26 document came out of Sharp 2 in 2011, and it provided a little bit more guidance, but you still got a lot of green in that table, and not really a whole lot of differentiating guidance on, well, which do I pick based on the PCI that I have on my roadway. And essentially the only thing you can take out of this table with respect of choosing between a microsurface or a thin lay is that it says, you know, industry says don't put microsurface unless you have sealed cracks, if the cracks are more than 1/4 of an inch. So that's where the red comes from in that table. But again, there's not guidance that is provided that helps to quantify, you know, how much life am I going to get based on the pretreatment condition of my roadway. So in 2010, 2011, our director here, Dr. Randy West, he directed me. He said, well, you know, we need to do this kind of stuff on the test track in conjunction with all of our other research, but we also need to do some research with pavement preservation where we don't have accelerated traffic, and we don't have pavements that are near structural failure in many cases. So we found Lee Road 159 back in 2011. We worked with the Lee County Commission and the Lee County engineer and got permission to use this roadway. And so we kind of dissected it, looked at all the distresses that were on it, and we laid out an experiment on Lee Road 159 that really turned out to be groundbreaking and very important. Now, what's unique about this roadway, it's a dead-end access road to a quarry and an asphalt plant. So what that means is in the inbound lane, you got empty trucks. In the outbound lane, you have loaded trucks. So there's a big difference in loading between inbound and outbound, big difference in pretreatment condition, inbound versus outbound, and a big difference in pretreatment condition by wheel path, because the road was widened back in its evolution back decades ago. So it really turned out to be a treasure trove of a great opportunity for data collection, because we had a lot of pavement surface area that was in pretreatment good, pretreatment fair, and pretreatment poor condition for all the different treatments that the states that you see on the sign there, in partnership with FP2 and FHWA, decided to include on this roadway. So our primary tool for data collection on Lee Road 159 in all of our now current test locations for pavement preservation is a 3D van. And the reason why I'm showing this picture is because I wanted to make it a point to tell everybody whenever I teach about pavement management, and I emphasize this, especially to smaller agencies. A lot of times you think, well, this is how you have to do it. And if you don't have a budget that allows you to do it this way, you just can't do it. And that's really not true, because the performance curves that Adriana is going to talk about, you can work with those curves if all you're doing is a windshield survey of your network. So this is really high end. It's the 3D van that does the auto cracking and everything. So you get rutting and roughness and texture and cracking, but you can do everything that Adriana is going to talk about just with a windshield survey. The other thing that I wanted to end with emphasizing here is we talk a lot about Lee Road 159, but that was really just our starting point. You know, we built the test sections on Lee Road 159, as I mentioned earlier, in 2012, but in 2015, we took what we learned there and built a bigger experiment on US 280. Lee Road 159 is about 5 minutes from the main NCAT office, and the US 280 test sections are like 5 minutes from the test track. So they're both super convenient, very different traffic levels, and we're seeing some significant differences in performance because of the traffic levels. And that was great for the southern part of the United States. As part of our partnership with the Minnesota Road Research Project with Minnesota DOT, we worked with them to install the same types of test sections on County State 8 Highway 8 and US 169 in 2016. So very much the northern versions of Lee Road 159 and US 280. And this was important because, as you can see on that US map, all the green are the states that are impacted by research at NCAT and research at MnROAD and the NCAT MnROAD partnership. The only thing that we didn't have on 8 and 169 was cold recycling, which was done on 159 and 280 down south. So on 70th Street in 2019, we were able to add that. So we got a huge test bed of really good information for hot climate and for cold climate with hot mix treatments, as well as emulsion treatments with hot stuff and cold stuff. And so with that kind of as a background, I'm gonna hand off to Adriana, and she's gonna get down in the weeds here with what all this means to you in your practice.
Perfect. Thank you. Let me. All right. Hopefully you all can see that.
Yes,
Good
we
morning,
see it.
everyone.
Great.
Thank you. Good morning, everyone. Again, it's great to have so many of you joining the webinar today. Just to continue with Buzz's background, he's talked about preservation, and I think it's a given that we have known for a long time that there's benefits to pavement preservation, but those benefits have not been well quantified. And that goes back to what he was showing with the different tables. So we don't know exactly what to use when we're making our decisions. And we also know that performance from the pavement preservation treated pavements, it's going to depend on many factors. So we're going to have, well, what treatment we're using. The existing pavement condition is extremely critical to pavement performance. And we have things like traffic level and climate conditions. So all of that, which is what we're covering with our study, we've been able to take those variables and just go a little further and try to get more detailed data that will give us a good expectation for what the different conditions are when we're doing our pavement preservation. So it all comes down to, again, you've probably heard this a million times, right treatment, right pavement at the right time. So if we get that combination, we should be able to get very good performance from our treatments. Again, Buzz said it, we started with the Road 159 10 years ago now. And at this point, we have been able to take more sites and just add to it. So that's been a lot of data that we've been able to compile and analyze over time. And that's what we're using to develop all of these curves. So I'm just going to show today some of the work that we've been doing, more focusing on the process on how to use the curves rather than just give you the results for the individual treatments. But then I'm going to point you in the direction of where you can find the data to just do the same thing for whatever conditions you're looking for. Some of the background again. So at this point, and this is where all this information is coming from, right now we are monitoring and analyzing 145 test sections altogether, combining everything that we have in Alabama and what we have in Minnesota. Low traffic, high traffic, all of that add up to 145 test sections. If we think of how much mileage that means, most of the sections are 1/10 of a mile, but not all of them. We have some shorter sections on Lee Road and the 70th Street sections are just short of 1/10 of a mile. So if we add up all the length, that comes down to about 13 lane miles. Again, that we've been monitoring over time. And if we were to put that in terms of lane mile years, just because that's something that's used typically when we're talking about remaining service life, which is something that I'm going to circle back to in a little bit. But if we take the length and the amount of time that each of those sections have been in service, that comes down to about 81 lane mile years worth of data that we have right now. So it's a lot of information. Thankfully, we've been able to do a lot with it. And it's just been fun to take all of this and try to put it into something that's useful and hopefully will help you manage payments better. So the big question is, how do we quantify this benefit that we've been seeing? So in this slide here, I'm showing on the left an untreated section from Lee Road 159. So that's our control. Nothing's been done to it. And then on the right side, we have a double chip seal section. Again, it's all from Lee Road 159. So 10 years ago, one was untreated, the other one got the treatment, and we can definitely see that benefit that we often talk about. But how do we quantify that? How do we put that in numbers and just use it for payment management purposes? So there's two things that we've been looking at. One is life extension and the other one is condition improvement. So when we talk about life extension, we want to say, well, how much more time will that payment take to reach a certain threshold? And what we have been doing in this case is to set that threshold as whatever defines the poor condition category. We use the MAP21 performance indicators a lot, because having so many sponsors from different states, it makes it challenging to find something that they all kind of have in common. Every state has their own way of just quantifying payment condition, but everyone knows MAP21. So that was the common language that everyone spoke, and we've been using that just to quantify those benefits. So if we think about cracking, and this is probably the most straightforward indicator that we can use. It's easy to see, it's easy to measure, to keep track of, to do quality control on that data. And it's often what we see change the most. So cracking, there's a lot of work that we have done around cracking, but it's certainly not the only thing that you could focus on. But I'm going to show you some examples right now. So what we have been doing is looking at an untreated payment. How long does it take for that payment to reach that poor threshold? And then look at the same payment or a payment in a similar condition that got treated, and how long does it take for that payment to get to that point? And then that difference is going to be our life extending benefit. We use 20% cracking by percent of total area. Is a little different from what we do with MAP21, because we're not only considering the wheel paths, we're considering the whole area, but it's close. Often cracking is concentrated within the wheel paths. So let's take an example with a double layer chip seal. I like this graph. We already have the fitted curves in here for the good, fair, and poor pre-treatment condition categories. We can definitely see that performance is going to be dependent on that pre-treatment condition. So if you see that green curve, that's for the good pre-treatment condition for that payment. You can see that curve is above all the others. It takes longer for it to drop and get into that poor condition threshold. Next one's going to be the fair condition with the yellow curve. It's close, but it's a little less. And then definitely if you're getting to that payment when it's in the poor condition, then that deterioration is going to be accelerated. So that confirms what we always have known, that you want to get to the payments when they're in that good to fair range. So those will be treated curves. And now we're going to go one by one and look at how do they compare to the untreated payment. So an untreated payment that started out with the same amount of cracking as what that other treated section had. And let's see what the difference is between the two curves. So let's take that green one, the good condition category, which is where ideally you want to be when you apply any payment preservation. And we can see now the dashed line will be our control section, our untreated payment. And we can see that condition starting to drop. And at around year 4 is where it will be in that poor condition category that we have established as our threshold. Now, for the treated payment, right now at year 10, we are not even there yet. But if we are to extrapolate, we would expect that payment to reach that 20% threshold at year 13. So for us to quantify that life extending benefit, we're just going to take that difference between those two curves. So the 13 year, when the treated payment is going to reach that point, minus the 4, which is the year at which the control section reached that point, is going to give us a life extending benefit of 9 years for that double layer chip seal. If we are getting to the payment when we are in the fair condition category, well, we will just do the same. So go through the same process. Now, in this case, at about year 3 is where we're going to be in poor condition if our payment was in the fair condition category to begin with, which is between 5 and 20% cracking. And if we go and look for our treated payment, we're expected to reach that point at year 11. So again, we take the difference between those two, and now we have 8 years of life extending benefit. So slightly less than if we were to treat that payment when it was still good. Now, if we go to a payment that started out in poor condition category, well, the difference is, or the life extending benefit is just whatever time it took for that treated payment to reach the threshold. So it was already poor. So we'll just look at the point here. It's around year 7. So now we have reduced our life extending benefit to 7 years. It worked out that this example, it seems almost like very academic because we just got 9, 8, and 7. It doesn't always work that way, but this was a nice one to illustrate that point. Now, how does that affect our decisions? Why is it important to be as detailed as possible? Well, let's assume we have 10 lane miles that we need to treat. And let's think about remaining service life and how many lane mile years we're adding if we're treating the payment in the different condition categories. So if we took that payment and treated it when it was in good condition, we multiply the 10 lane miles by the 9 years of life extending benefit, and we're adding to our network 90 lane mile years that we have gained. If we did it in the fair condition, now it's the 10 lane miles times 8 years. So it's going to be 80 lane mile years. And again, same thing. If we're doing poor condition category, now we're down to 70 lane mile years gained. The reason why this is important is because cost is going to be about the same no matter what. If anything, it might cost you more to treat the payment when it's in poor condition because of the surface prep that you have to do. So assuming it's just the same cost by square yard or the same unit cost, would you rather have 90 lane mile years added to your network or 70? It does make a difference. So this is why we're trying to give more guidance so you can have a better estimate based on the existing conditions and then take the best decision. Another thing that I wanted to point out here, we saw the life extending benefit, and it doesn't seem like much going from 7 to 9. So it seems like we have a narrow range here. It just varies by 1 year, but it does make a difference, like I showed there in that previous slide. But one thing that I also wanted to point out is the time that it took for those treated payments to reach that poor condition category. So maybe the life extending benefit, it seems like it doesn't change too much, but also let's think about that performance period when that payment's going to be below that poor threshold. So if we're in the good condition category, we're going to have good performance or good to fair performance for 13 years before we're reaching, let's say, an undesired level of service. But if we're in the poor condition category, that's almost cutting half. So again, we have to look at both sides to make a decision. Are we planning on doing something else to that payment with or beyond those 7 years? So maybe we use this as a band-aid, or are we looking more into the future where we want to keep that level of service and that good performance for a longer time? I also mentioned the condition improvement benefit. So in this case, we were looking first at that difference between those curves horizontally. Now let's look at it vertically. So let's see how much less distress we see if we treat the payment. So what the difference will be between those curves. And there's different things that we are going to see here, and we may see one or several of these bullet points that we have here. So we may see an immediate benefit. We call that the performance jump. So right after we do our treatment application, we see an improvement in performance in that indicator. It could be that we see a sustained benefit over time, or it may be that we have a different deterioration rate for a treated payment versus an untreated payment. So it could be one or combinations of these different situations here. So again, going back to our double layer chip seal that I've been using as the example, one thing that I also wanted to point out, if we have a payment that's in good condition, maybe that condition improvement benefit won't be so obvious in the beginning. And that's because the payment's already good. So there's only so much more than you can do to improve the condition here of this payment. But there comes a point where you can really start to see that preservation treatment pay off. So one example, again, we can take that difference between the two curves and just see how many or how much less cracking we will have for our treatment. But let's say here in year 5, our treated payment still in the good condition category. Our untreated payment is already in the poor condition category. So that definitely does make a difference. So even though we don't see much of a condition improvement benefit in the beginning, later on, it starts to really be evident that when we do apply our payment preservation, we're definitely going to get better results. Now, if we have fair or poor payments, maybe we have curves that are almost parallel. So we could express this as an average condition improvement. So we take every year and look at the differences and just take an average. That's one way to see it, one way that's easy to visualize. So in this case, we have an average crack reduction of around 20%. So if you took a payment that was in fair condition category, applied the double chip seal, on average, you're going to have less, 20% less cracking each year for our treated payment. One way that the benefits are quantified often is also looking at the area under the curve. And we can definitely do that. So in this case, the area is bound by the curve that goes for the treated payment, and then our threshold, which is the 20%. So we could quantify our benefit that way. One thing is that it's not as easy to visualize. So you just get a number that's an area, you know, the bigger the number, the better. But I like to see or speak in terms of the life extending benefit and then that condition improvement, because if you say 20% less cracking, that's something that you can definitely see better than just the area, but we can definitely quantify it this way also. So that was for cracking, but what about some other performance indicators? So one thing that we have learned is that depending on conditions, there may be other things that are more relevant. And a good example is the Minnesota sections, which will be our cold weather locations. They rely heavily on IRI for the payment management decisions. And we have definitely seen IRI being a bigger factor in some cases than cracking. So we can take the same type of logic and apply that to IRI and just get our IRI curves and calculate that life extending benefit the same way. So in this case, we're thinking our condition threshold will be 170 inches per mile, which again will be the threshold for the MAP 21 criteria to define a payment as in poor condition. And in this case, I'm going to talk about a combination treatment, which will be a thin lay over a scrub seal. So we've done the same thing. We took our data, we fitted curves for the untreated and the treated payments. And so you'll see the solid line is for our thin lay over the scrub seal, and then the dashed line is going to be our control or untreated payment. So we go through the same process. In this case, we will, if we don't do anything, we take that payment, we don't do anything with it, at around year five something, we'll reach that poor condition threshold. And for our treated payment, that is expected to happen at around year 12. So once again, if we take that difference, we're going to have more than 6 years of life extending benefit in terms of IRI for that payment. Another thing that can be evident here is that immediate improvement in IRI as a result of putting down this combination treatment. So in this case, we were able to lower that roughness, and now we have a difference in our IRI immediately after treatment of 45 inches per mile. So that's another thing, short-term or immediate benefit that we want to see. In some cases, maybe we don't see that performance jump. So this is a single chip seal, again, from our Minnesota sections. And you can see there immediately after treatment, we actually made it a little worse. So it's just went up the IRI by a few points. But the important thing is that over time, we were able to lower the deterioration rate. So the real benefit comes later on as the difference when we have the payment reach that poor condition threshold. So we reduced that deterioration rate, and that resulted in a benefit of 1.6 years of life extension. Now that may not sound like much, but let's think about the treatment that we chose. So this is a single chip seal. If you're having IRI problems, that's probably not your go-to. But if you put it down for another reason, and you're kind of getting this as a bonus, I think that's an important thing to point out. So we are seeing benefits again from the treatments, even if they might not be much. If you want to see more on our IRI, specifically, we have a pavement with thin overlays for the Minnesota sections, where we have done all of this analysis, and you can look, we actually have tables of the life extending benefit. In this case, we are focused only on the thin overlays, but we've been working with the different treatments. So that's something that we'll be publishing in the future. All right, so this brings me to the demo that I wanted to also show with the online tool. I've shown you the process on how we can use the data to get those benefits. And now I'm going to show you where you can find the data. So we've been developing an online tool on NCAT's website. It's right there. It's live. It's accessible to anyone who wants to play with it. Right now, we only have performance data for the Lee Road 159 sections. So that will correspond to the low traffic and warm climate. I must make it clear that this is all preliminary data. It's subject to change. We're constantly updating. The curve is going to change as we add more data, and it may vary slightly the way it looks as a fitted curve. But right now, I think it's a good starting point. So let me switch quickly here. Oop. Right, one moment. And I guess I'm gonna start from the beginning, so you can see how to get there. So if you go to NCAT's website, which is ncat.us, you'll find here a payment preservation tab at the top. So if you click on it, it's where you'll get everything that relates to our payment preservation research. If you go to this menu here on the left side and choose Observe Performance, that's where you can load our tool. So I'll just walk you through it quickly. You can choose the treatment type. And I'm gonna do, I really like the way the double micro came out. So if you choose that, first thing you'll see is a picture. This is the current condition of the pavement. So you can have a good idea of what that looks like today. And I'll remind you that's 10 years old. You can also go through charts with IRI, and this is pre-construction, post-construction, and then the current number. So that's how IRI has progressed over time. We have the same thing for rutting. You can see it's color-coded to match the condition categories for map 21. Again, green is good, yellow fair, red is poor. The next thing, you can see our overall section condition. So this is as of now. It will be classified as in fair condition overall. We have cracking of 9.5%. So that's in the fair condition range. We have rutting of 6.8 millimeters, and the IRI is in the 90 inches per mile range. So 2 fairs and 1 good makes it a fair. Now, the next thing you can do is select your pre-treatment condition category. So let's say we chose a good pavement. And now it's going to show you the curves for the treated and the untreated. So this is where you can take that information and calculate those life extending benefits. We have it here at the top, the time to pour for the control section. So it took about 4.5 years to get to a poor condition category. We at year 10 have not reached that point for the treatment. So that's why there's nothing in here. I guess we could extrapolate. We might add a couple of years, but again, because it's changing, we don't want to go too much into the future. But it gives you a good idea. And it also gives us an average crack reduction for this treatment. So on average, 20%, 20.7% less cracking. We could also just look at one point in time. So let's say year, I don't know, year 8, for example. And it will tell us what the crack reduction was specifically for year 8 or any other year that you want to choose. Let me choose another one. Scrub seal, I think, was a good idea. This one, if we choose the scrub seal again, we'll see the picture and all the different indicators. I'm going to choose the fair condition category for that payment. And now in this case, we do have a time to pour for the treatment, which is 9.4, and for the control, which is 1. So we take the difference. Now we know that there's over 8 years of life extending benefit for that scrub seal. And that's the case for all the other treatments. We have the same information for all of them. Another thing that I wanted to show quickly here is if you click on the treatment location, it will give you a map of where Lee Road is located and the different sections that are along are the length of the project. And if you want to know more on construction, so if you're curious to see, well, that double layer chip seal, I really want to see what you used, it will give you some construction information. So what the chip size was, the emulsions that were used, emulsion rates, aggregate type. So if you wanted to get those type of details, you can get to those. And again, this is something that you can just get to. It's not password protected. You can just navigate through it and just play with it and let us know your feedback if you think there's something that we can improve. We're constantly trying to update and make it better. Another thing before I pass it back to Buzz is going back to this menu here, we have the payment preservation resources, and this is just a list and links to all the papers that we have published. So if there's anything that you want to look more into detail, you can get to it from here. And I think that's about it for me. So I'll pass it back to Buzz.
Thanks, Adriana. We appreciate that, and hopefully that y'all found that to be some really, really useful and relevant information. One of the questions in the chat box, Adriana, was if you can put a link to that, a direct link to the web tool in there to share with everybody. So you may want to take a look at that while I'm finishing this up here. So to kind of pull all this together and give y'all some implementation takeaways. I think it's important to note that we've had what I would consider to be a positive performance experience from all the treatments that we've used. Like we've not, in my opinion, anywhere we've applied any of these treatments, we've not seen something that's blow out on us or has not met our expectations. The footnote to that is that we always emphasize the importance of good materials, good designs, good construction effort, and then quality inspection. So we kind of talk about that 4-legged stool with the 4 things that are important there. And if you do all those things, our experience has been positive with all the treatments that we've applied at all these locations. So as you saw in Adriana's presentation, I think that this experiment continues to do a really good job as we monitor these test sections out into the future and quantifying the kind of the delta X and the delta Y in the pavement life cycle curve that we started the presentation with. So the life extending benefit is the shift in the X axis, and the condition improving benefit is going to be the shift in the Y axis. I'm really excited about this web tool. We started the experiment out with just kind of static PDF reports, and the web tool has been an outstanding innovation that Adriana has worked really hard to develop. It's really nice to be able to dive into that and do your own queries and compare the data that you want to compare. I always try to stress that pavement condition assessments can range from really simple windshield surveys and a 1 to 10 ranking to very detailed pavement condition assessments with 3D vans or manual surveys. That's what we were doing when I started with Alabama DOT, were manual surveys. But the important thing is if you're a smaller agency maybe and you're not already doing this, you got to start. You got to get the data points that Adriana showed on those curves. You've got to begin to understand what are the changing conditions of all the roads that are in your infrastructure that you're managing, so that you can use the data that we're generating to support your decision making process. So if you think about kind of the delta X and the delta Y, the X axis shift, you can use that to kind of compare overall return on investment for the treatments that you're evaluating or that you're considering, and then you can look at a specific point in time, like a budget cycle, for example, and say, okay, what's my Y offset? What's my delta Y? What kind of a shift am I getting as a result of the investment that I'm making? So hopefully in this webinar, you've got a good feel for how you can use the data that's being generated from the NCAT Menroad partnership and all the different test locations. And if you have any questions, any follow-up questions for us, there's Adriana's email address and my email address. And we're always very eager to, everything that we do is about implementation. We really focus heavily on the implementable products in the research that is funded here. I saw a lot of names, participant names from state agencies that are financial partners that are supporting this research. And it's all about implementation so that we can provide a good return on the research investment that all of these states are making. So that's all I've got, Travis, and I'm going to stop my share and hand back off to you.
All right, that sounds good. We've had a couple questions come in, and I think that it's always great when we have that opportunity to answer some of those. So Adriana, I think this first one would be great for you. It says, and what it says is what happens if the life extending benefit is reached. Is this you treat the pavement again, mill and fill, etc. And I think we want to make sure and clarify that it's like the pre-treated condition is maybe more where we're headed with that. But I'd like to let you answer that and have that discussion.
Sure. So that's definitely going to depend on each agency's policies, so that it's possible that we apply another treatment, but we're now going to be in the poor condition threshold. So what treatment options we have to be effective are going to be more limited. So it's possible that you're looking more into the rehab side of things. If you're a little more proactive and you just don't wait until you reach that threshold, you may keep doing preservation over and over and just kind of keeping that level of service in that fair or good range. So again, it's sort of to help you see into the future, to put it that way, and plan ahead. But yeah, it's all going to be dependent on everyone's policies, I guess.
Yeah. And I kind of want to add to that a little bit. The part of the country that I grew up in the Western US, chip seals are what we put on roads, and that's what we did there, and over and over and over again. So you got several applications of chip seal, maybe with that 6 to 10 years in between applications, and treated it over and over and maintained the structure underneath by protecting that with that, again, like you're saying, Adriana, with that proactive aspect there. Another question that came in, Adrian, I'll push this one to you as well, is what would be an equivalent PCI to the standard of say 20% cracking in that threshold? So I realize that's a tough nut, but I want to give it to you.
I would say, and I saw the question, so I went back to the ASTM data curves. What we're seeing is mostly in the low severity condition for the types of cracks. If it was all alligator cracking, I would say we're probably at a 70, 65, somewhere between 65, 75 for a PCI when we have that much cracking. It depends on the type of cracking. So one thing that I should clarify is we're not differentiating between what type of cracking this is or what severity, because that's how MAP 21 does it. So it's just cracking. But certainly that's also part of what the agency has to do and make sure, well, can I live with longitudinal cracking, or is it alligator cracking? Now it's a little more serious. So again, this is at the network level, giving you a tool to start sorting out, well, this may be a good candidate, this may not, and then go there and see at the project level if this is really what you want to apply.
Yeah. And I think that's so important as well, that we can't manage our pavements from the office. That we do need to go out there and see what kind of cracking it is. If we just look at a section that has a percentage of cracking, just like you're saying, if it's alligator cracking, it may not be a preservation candidate. And so we run into that. And I can never leave that MAP 21 discussion about the cracking without having the little bit of part of the discussion where it's very binary. With the MAP 21 standards, either it's cracked or it's not cracked. There's no discussion about the thickness or the severity of the crack in there. And so sometimes what we see as a very small crack, just is a crack, is not going to take on the water that a large crack or a wide crack would. And so I always love to make sure we keep that in reference as we go out there and look at those pavements. So,
and if we know our pavements better than anyone, like as an agency, the agency will know and will recognize the type of cracking that they often see, and just have a better feel for whether the 20% is still acceptable, or do we focus now on IRI or any other indicator as well. So we're trying to cover all the different possibilities here.
Yeah, absolutely. Buzz, do you have any input on either one of those questions?
No, I think we covered it really well, and that's a great point that you made about the severity level of the crack. Another thing that I'll point out about the data from Lee Road 159 is one of the things that we learned from 159 to making the jump to 280 was the thin lays that we put on 280 were balanced mixed design for that era, but the thin lays that we put on 159 were all volumetric designs. So there are two sections there that have a higher recycled content. One of them is 50% fine fractionated wrap, and the other one is 5% post-consumer recycled asphalt shingles. And there's a lot of cracking in those two test sections because they were just volumetric designs. So if you look at the kind of the quality of the age binder, it's pretty stiff binder mix, and we've made some significant improvements on that with balanced mix design with the thin lays that you need to know going into those curves. And I think you see that in the 280 data and also in the Minnesota data.
Yeah, absolutely. And one more question just popped in here real quick, and I think it's a great point to make there, that IRI as a performance indicator is lagging in terms of pavement preservation. And I wholeheartedly agree that, that once we start to lose the ride, the cracking, had started years beyond that or before that. So Adriana, how is IRI being used in pavement preservation? How do you see that as a good indicator of when we should and should not get on?
I think it's just that there's a lot of agencies that are still very dependent on IRI to just make their decisions. And if we can see benefits like what I showed with reduced deterioration rates, that can help us look more into that. I hope that answers the question, but bottom line is there's still a lot of agencies that put a very heavy weight on IRI, and this gives us an idea of what the effect of the different treatments can be for IRI.
Yeah, well, and I think your curves speak a lot to that, right? They really do, that we can see that the cracking has gone and the IRI then catches up and shows that. And so I think that's really what a lot of that comes down to, is it speaks to the fact that we need to, if we're going to live in a preservation environment, which I feel strongly we should be as good stewards of the pavement and the taxpayers' dollars, that we need to be watching that cracking first if we're going to do preservation, because once we lose the ride, then we're a little beyond that. So, okay, well, I think that's about all we have here. Let's see. I think that's a statement more than a question, so we'll go with that. I do want to share real quick. Let's see if I can get this up the way I would like to. I want to invite everybody to always, I want to invite you to check out our YouTube channel called Training in Your Pocket. There's some fantastic little short videos in there. When it comes to preservation, there's a great one on crack type identification. Will help you look at, you have longitudinal cracks, transverse cracks, temperature cracks, or alligator cracking. And then we absolutely need to make sure we close this out and invite you all to come back with us in a month. So in a month, we're going to have our next installment of our firm research to implementation webinar series, and it's going to be on better design and construction of open graded friction courses that are drainable surface mixes. And we'll have Buzz on there. We'll have Jim Musselman, who handles a lot of our OGFC type of work here, and we'll probably have a special guest again. So given that, I want to go ahead and sign off and thank you all for joining us again. We look forward to seeing you next time.